April 8, 1943. Sky over the city of Rouen occupied France. Oberleutnant Hans Kruger of Jagdgeschwader 26 watched with disdain as the new American fighters slowly climbed under his formation. "Do they call it an airplane?" he muttered on the radio. They were P-47 Thunderbolts, thick, heavy, with fuselages that looked more like flying barrels. On board the Focke-Wulf 190s, the German pilots laughed. One of the aces summed it up. "It's barrels of gasoline with wings." But that laugh was about to be silenced. In less than 2 years, the same derided plane would become the largest aerial destruction machine of World War II. Not for maneuverability, not for elegance of flight, but for something that the Luftwaffe never took seriously: the weight of American industry. This documentary will tell how an underrated aircraft, equipped with 8 .50 caliber machine guns and powered by a 2,000 horsepower engine, turned the sky of Europe into a concentrated fiery hell. How what seemed slow turned out to be power, and how Germany's best pilots discovered that, in the face of the mathematics of mass production, individual skill was not enough. They laughed, but the thunder was already coming. But before we dive into the skies of France in 1943, there is one statistic that defines this whole story. Between 1943 and 1945, a single American fighter model, the P-47 Thunderbolt, was responsible for shooting down 3,552 enemy aircraft in aerial combat, destroying 3,315 on the ground, eliminating more than 9,000 locomotives, 6,000 tanks, and no less than 150,000 vehicles. And the most ironic, all this was done by the machine that the Luftwaffe called an engineering error. How did a 7-ton plane, which climbed with difficulty and turned slowly, become the nightmare of the skies? What happened to make the German laughter become silence? This is the story that begins now, a story of steel, numbers, and destiny. If you believe that the story should be told with precision, respect, and memory, leave the like and subscribe. This helps to keep research alive and to give voice to the forgotten echoes of World War II. At the beginning of 1943, the skies of Europe were still the absolute domain of the Luftwaffe. Their aces, shaped since the Spanish Civil War, believed that aerial combat was an art, a dance of reflexes and precision. Adolf Galland, the ultimate symbol of this doctrine, said that the true pilot did not need numbers, only instinct. Germany viewed aerial combat as an aristocratic duel where one man's talent could decide the fate of a battle. This belief, inherited from the First World War, transformed the Luftwaffe into a tactical elite, but also into a blind force to the industrial world that was being born on the other side of the Atlantic. While American engineers turned civilian factories into war assembly lines, the German command still believed it would win by the genius of its pilots. In 1943, a German ace could fly 300 missions, an American at most 20, and for Germany that was enough. They had irreplaceable men. The mistake was precisely there. The coming war would not be decided by irreplaceable men, but by replicable machines. Luftwaffe intelligence reports downplayed the American effort with mathematical coolness. According to his estimates, the United States would be able to produce about 10,000 aircraft per year, a number already considered impossible. However, by the height of 1944, American factories were delivering more than 96,000 planes in 12 months, each of them with standardized mass-produced parts, capable of being changed in the field without logistical delay. Germany, on the other hand, relied on manual workshops, fine-tuning unique components. What the Germans called technical perfection, the Americans called the productive bottleneck. And when time became the real enemy, the difference between a hand-tuned engine and a mass-produced one came to mean victory or annihilation. This divergence of mentality began even before the first confrontation. While the American High Command invested in standardization programs, maintenance planning, and global supply systems, the Luftwaffe relied on the prestige of its aces and the brute power of the Daimler-Benz engine. German doctrine did not believe that quantity could defeat quality, and that's why the P-47, a 7-ton behemoth, seemed to them a conceptual mistake. A plane too heavy to maneuver, too slow to fight, too expensive to sustain. What the Germans didn't understand was that the Thunderbolt wasn't created to compete by the same rules. It had been designed to break them. In the winter of 1942, even before it entered combat, Luftwaffe field reports classified the P-47 as an underperforming machine. The word used was Traktorflugzeug, tractor plane. No German driver imagined that within 2 years, this tractor would become the symbol of a new era, all-out industrial war. The American philosophy was not to defeat the enemy in a fair duel, but to crush him with the force of the system. An American factory could produce in 1 day what a German workshop did in a week. An assembly line could deliver engines and ammunition faster than any German recovery plan. The power that would come from across the Atlantic was invisible to the naked eye, until it appeared in the form of aluminum, fire, and noise. It is at this point that the irony begins to take shape. While the Germans extolled the talent of their aces, the United States trained 30,000 new pilots a year. And with a detail that the enemies completely ignored, each American arrived at the front with 400 hours of flight time in advanced aircraft. The average Luftwaffe pilot in 1944 would have been less than 100. The difference was stark but invisible to the eyes of those who believed that the war was won bravely. They were ready to face nights from the air. What came, however, was a tide of steel. In terms of fuel, the disparity was even more devastating. While Germany relied on increasingly bombed refineries, the United States produced 90% of all the world's aviation gasoline. Allied depots arrived in England in endless convoys, and the P-47's fuel tanks allowed it to fight long missions over enemy territory. The plane that the Luftwaffe called short-legged would become, in 1944, the first to escort bombers to Berlin and back. The air war that the Germans envisioned as a contest of skill had turned into a confrontation of logistics in which every liter of fuel was worth more than an individual victory. And when it comes to ammunition, the contrast is almost unbelievable. The P-47 carried 3,450 caliber cartridges. This meant that a single plane could sustain continuous fire for more than 30 seconds, an eternity in aerial combat. In comparison, a German fighter such as the Messerschmitt Bf 109 carried a maximum of 200 cannon shells. It was the difference between a gust and a storm. The Luftwaffe got into a numbers war and didn't realize it. At this point in the story, it's worth a break. During the war, the United States produced 10 times more aluminum than all of Nazi Germany combined, 10 times more metal for wings, fuselages, and ammunition. It is a fact that completely changes the meaning of the word power. If this number surprises you, leave a comment now with the phrase absolute power, because that's exactly what this statistic represents, the absolute power of industry over tradition. But German arrogance had deep roots. It came from the belief that war was a matter of genius, of refined engineering, of technical honor. It was a mentality that ignored the weight of production, the efficiency of transport, the simplicity of repair. Each German fighter was a masterpiece, and for that very reason fragile. Each P-47 was a piece of a larger machine, designed to be replaced, repaired, and returned to the fight in a matter of hours. The Luftwaffe did not understand that it was facing not only pilots, but an industrial system that functioned like a living organism. In the reports intercepted in 1943, German officials ridiculed the American model. One of them wrote, "The enemy is building airplanes like someone who builds tractors. Maybe it will work for them." And it worked, because modern warfare didn't need elegance. It needed permanence. While the German fighters required 20 to 30 hours of maintenance for every hour of flight, the P-47 was capable of returning to combat after brief field repairs. It was the triumph of functionality over aesthetics, the same concept that would make Sherman tanks, jeeps, and Liberty ships the instruments of inevitable victory. The German belief in isolated technical superiority had become a trap. The P-47 was everything they despised, and exactly what they couldn't beat. Over the next few months, when the first Thunderbolt returned to base covered in holes and still flying, Luftwaffe Command would realize too late that it was fighting an idea, not just a plane. And it is in this turn of perception that the real story begins. Because what would come next would not be a victory, but a statistical humiliation, a morning in which a single American pilot, alone and injured, would prove how far the tractor plane could resist. When the Republic P-47 Thunderbolt first appeared in the skies over Europe in April 1943, it seemed like a mistake. A huge aluminum body, a disproportionate nose, and an engine sound that was more reminiscent of a tractor than a fighter jet. For German pilots, accustomed to the slender elegance of the Messerschmitt Bf 109 and Focke-Wulf 190, this new enemy was a visual joke. Oberleutnant Heinz Marquardt, a veteran of JG-51, recorded in his diary, "They are sending flying barrels. Heavy, slow, dull. The Luftwaffe could not ask for a better opponent." The British, watching from their Spitfires, laughed too. An RAF pilot commented, "If the best evasive maneuver of this plane is to run inside the cockpit, we are safe." Even within the American ranks, the P-47 was received with suspicion. Many pilots coming from training in P-40s and Spitfires believed that Republic had created an aerodynamic error. It was the largest single-engine fighter ever built, 7 tons in maximum weight, 11 meters in wingspan, and an 18-cylinder Pratt & Whitney R2800 double Wasp radial engine. Everything about it was exaggerated. Everything about it seemed contrary to what was expected of a fighter. But this appearance concealed a completely new philosophy of warfare. While European engineers sought lightness and agility, the Americans bet on mechanical brutality. The P-47 didn't have to be sleek. It had to survive. The radial engine, which the Germans considered primitive compared to liquid-cooled inline engines, was actually a floating fortress. With no vulnerable radiators, it could continue to function even after being punctured. The tubes of the turbocharged supercharger ran all the way through the fuselage, feeding the engine compressed air at altitudes where German fighters could barely breathe. It was a machine built not to maneuver, but to resist. The initial reaction of the American pilots who received the plane was one of astonishment. Many doubted that something so heavy could even get off the ground, and in fact, the first months of operation were tough. The P-47 required skill and strength to take off. Its lateral torque was brutal, the required track length huge. It turned slowly, climbed with difficulty, and plunged like a rock. But when the pilot managed to master it, he discovered a power that no other fighter of the war possessed: an uncontrollable diving ability, furious straight-line acceleration, and a resistance that seemed to defy the laws of physics. At the helm of Republic Aviation, Alexander Kartveli, a Georgian engineer who had become a naturalized American, had understood something that no one else did. When the U.S. Army asked for a high-altitude interceptor, Kartveli responded with a radical concept: to build the most robust and armed fighter ever seen. The P-47 was the opposite of European doctrine. It was a lone fortress, a fighter capable of absorbing damage and continuing to fight. Its 2,000-horsepower engine could maintain full power at 27,000 feet, where thin air paralyzed German engines. The exhaust gas turbocharger, a unique innovation, kept the plane's performance at the edge of the stratosphere. While the Focke-Wulf 190s lost power above 25,000 feet, the P-47 still accelerated. In the hangars, mechanics discovered that the plane was also a maintenance marvel. Its modular structures allowed for quick replacements. What in Germany took days to repair, the Americans solved in hours. And what seemed like a waste of material, thick aluminum plates, double wiring, redundant systems, would become the essence of the invulnerability that would soon shock the Luftwaffe. German arrogance, however, persisted. In intercepted reports, Luftwaffe officers called the P-47 a symbol of American ingenuity. They claimed that no experienced pilot would choose a plane that he could not turn in combat. But what the Germans ignored was that the air war was changing. The romantic duel between aces was fading. In place of elegant curves, firepower, altitude, and energy entered. The P-47 was the harbinger of this new era, the era of terminal velocity and raw power. While the Germans ridiculed, the Americans began to understand what they had in their hands. Each Thunderbolt carried 850 caliber Browning M2 machine guns, 4 on each wing. No other Allied fighter possessed so much concentrated firepower. When they all fired together, they formed a storm of 13mm projectiles, capable of cutting a plane in half in less than 2 seconds. It was concentrated power in the form of sound. And this sound, muffled by the clouds, had not yet been heard by the enemy. The British, still skeptical, nicknamed the P-47 Jug, short for Juggernaut, the steamroller. The nickname, which started as a joke, would eventually become an omen. In the workshops at the Boxted base in England, Major Donald Blakesley, a former RAF pilot who had switched from the Spitfire to the Thunderbolt, realized the hidden potential of the machine. He said, "This is not a fighter jet. It's a cannon with wings." His phrase, initially taken as irony, would become tactical doctrine months later. The first squadron equipped with P-47s arrived in England in January 1943, the 56th Fighter Group. In the first familiarization flights, The pilots complained about the slow climb and the difficulty of maneuvering, but when they tested controlled dives, they discovered something unexpected. The plane not only maintained stability at speeds above 800 km/h, it accelerated beyond what any German fighter could keep up with. Physics was reversed. Weight, once seen as weakness, became strength. The P-47 dived like a bullet, evaded with ease, and climbed back into combat before the enemy could react. Major Hubert Zemke, the group's commander, summed up this discovery in one sentence: "Don't turn with them. Dive, shoot, and climb. That's how you win with Thunderbolt." It was the birth of a new form of air combat: boom and zoom. The tactic that used energy, altitude, and mass to destroy the enemy without exposing themselves. But at the beginning of 1943, none of this was known. What the Germans saw was only what the eye could judge: a slow, heavy, clunky plane. They didn't know they were looking at the beginning of the end. The technical arrogance of the Luftwaffe, which had led them to dominate Europe in 1939, now blinded them. They had entered a war they did not understand, a war in which the enemy made more engines than they made wings. In the skies of Normandy, still distant in time, the echoes of this era would multiply. But the first hint that the flying barrel was something more than it seemed would come soon. An American pilot, injured alone with the plane reduced to an aluminum sieve, would prove that the monster everyone mocked did not just fly, he refused to die. And when it landed, covered in holes, the Luftwaffe's laughter began to fail. The first months of operation of the P-47 Thunderbolt were marked by chaos, frustration, and fear. To many American pilots, accustomed to light and sensitive fighters like the P-40 Warhawk or the British Spitfire, the new plane seemed like an aberration. Major Hubert Zemke, commander of the 56th Fighter Group, described it as a metal monster that seemed to fight anyone who tried to tame it. In fact, he fought. The brutal torque of the R-2800 engine was capable of spinning the aircraft on the axis during takeoff if the pilot applied power abruptly. The tall, narrow landing gear made each landing feel like a life-and-death gamble. Many did not survive. Between September 1942 and January 1943, the 56th lost 18 pilots and 41 aircraft in training accidents without ever engaging the enemy. It was as if the machine tested its own chosen ones before letting them go into combat. Reports from boot camp in Bridgeport, Connecticut were harsh. Inexperienced pilots went into a tailspin when trying to maneuver the plane at low speeds. The P-47 dived so hard that many discovered the phenomenon of compressibility, when, at extreme speeds, the flow of air formed shock waves in the wings, locking the controls. No one in American aviation had experienced this before. The rigid wings and massive fuselage created forces that seemed to defy the human body. Thunderbolt did not forgive mistakes, said the instructors. A small faltering in takeoff could mean a fatal spiral. A mistake in the descent could break the plane in half. It was a fighter that killed its own pilots before killing the enemy. But there was a detail that few realized. All this brutality hid an advantage. Those who learned to deal with the monster discovered unprecedented brute force. Lieutenant Robert S. Johnson, a young man from Oklahoma, described his first flight almost reverently. "You didn't fly the P-47. You guided him as one who held an angry animal, and when he answered, you felt like nothing could stop him." The feeling of acceleration, the roar of the radial engine, and the stability at high speed gave the pilot the impression of being inside a locomotive. The Thunderbolt didn't rise fast, but once at altitude, it became unstoppable. However, the losses continued to pile up. During the first 3 months of 1943, nearly 1 in 5 P-47s delivered was destroyed in accidents. The military press began to doubt the project. RAF officials even suggested that the Americans abandon the model and adopt the Spitfire full-time. Boeing itself, observing the results, considered that the P-47 program could be doomed to failure. It was a phase of disbelief and shame. The machine seemed greater than the human capacity to control it. But while the pilots suffered, the American industry did not stop. Republic Aviation worked day and night, fine-tuning details, testing new propellers, redesigning hydraulic systems. The engineers called the plane a dinosaur with purposes. Every problem encountered in the field was documented and fixed in a matter of weeks. In less than 6 months, the P-47 has undergone more than 700 modifications, from reconfiguring fuel lines to installing reinforced dive controls. It was the first American plane to be improved in real time, with direct feedback from pilots at the front. What Germany did through master engineers, the United States did through statistics. The philosophical difference was beginning to emerge. The Germans trusted the instinct of the individual. The Americans trusted the process. The P-47 was not the most intuitive plane, but it was the most perfect. Each pilot who died in training contributed, unknowingly, to the next one surviving. It was evolutionary engineering on an industrial scale, and slowly, the dinosaur began to show that it could also run. Over time, pilots learned to respect the monster's rules. Zemke laid out a clear doctrine: never fight him. Use weight, use power, maintain altitude. The plane will take care of the rest. Instructors have created new training methods based on energy and torque control. The mechanics found that the key to performance lay in the precise calibration of the turbocharger, which needed to maintain constant pressure even at extreme altitudes. The learning curve was painful, but the reward was unmatched. The moment when the Thunderbolt began to inspire respect came with the first real combats back in April 1943. Although the Luftwaffe continued to despise the aircraft, return reports showed something unheard of. P-47s hit by direct fire from 20mm cannon returned to base, damaged but whole. One of them, after an attack on France, landed with 21 cannon holes and more than 100 machine gun marks. The engine continued to run. The pilot came out alive. It was the first indication that what seemed heavy was actually immortal. The Thunderbolt's absurd resistance began to generate curiosity among the enemies themselves. German intelligence received reports of American fighters returning from the front with impossible damage. At first, they considered it propaganda. Then they began to investigate. They found that the radial engine and pressurized fuel system were nearly indestructible. The plane could lose a partial wing, or even half of its tail, and still remain in the air. And the armor that the Germans called over the top was exactly what made the P-47 the first truly error-proof fighter. The irony grew. The Americans had built an airplane that punished their own pilots, but saved them in actual combat. What was seen as a defect became an advantage. Instead of being the most agile, the Thunderbolt became the most stubborn. He didn't win by grace. He won by persistence. And every time a pilot survived an impossible attack, the myth grew. Luftwaffe officers, confident in their tactical superiority, still scoffed. In an intercepted July 1943 report, Commander Joseph Pips Priller wrote, "The new American fighter flies like a truck, flips like a train, and climbs like a pregnant cow, meat for slaughter." The slaughter, however, was about to be reversed. At the end of that same month, one of these pregnant cows would return from France in flames, bringing a wounded pilot, surrounded by smoke and shrapnel, and would prove, on its own, that German laughter would not last long. The whole world would hear about Robert S. Johnson, and the day the plane that no one believed was born to fight defied the impossible and flew home. On June 26, 1943, Second Lieutenant Robert S. Johnson took off from a base in England, flying his P-47C Thunderbolt, serial number 4276341. The mission was to escort bombers over occupied France, routine for the 61st Fighter Squadron, but still a challenge for pilots who barely understood the limits of the colossal machine they were driving. When the group crossed the English Channel, the sky seemed clear. Moments later, the clouds parted, and from above descended the Focke-Wulf 190s of the legendary JG-26, led by Wilhelm Galland, brother of the celebrated General Adolf Galland. The first volley of the Germans hit Johnson squarely. Fragments of glass, oil, and blood filled the cabin. An explosion opened a hole in the fuselage. The panel burned. The engine, covered in flames, began to sputter. In any other fighter, it would be the end. But this was no ordinary plane. Johnson tried to jump, but the canopy was locked, welded by the heat. He was trapped in a metal tomb at 27,000 feet. The fire extinguished itself. The Thunderbolt leveled off, as if refusing to fall. The pilot, injured and without frontal vision, decided to try the impossible, to return home. At 20,000 feet, a lone Focke-Wulf reappeared. The German pilot, anonymous to this day, positioned himself behind and opened fire. The 20mm gun spewed bursts that went through the American fuselage, piercing the tail, tearing the rudder, and hitting the engine again. The P-47 swayed, but did not give way. When the German approached, believing he had finished the job, he saw something that left him immobile. The plane was still flying. The enemy was alive. He repositioned, shot again, then again. All 20 rounds of the cannon were fired. The 13mm machine guns went into action. No response. Just that mutilated giant, advancing in a straight line without giving in. When his ammunition ran out, the Luftwaffe pilot flew side by side, watched the American covered in blood, and, in an almost human gesture, waved and drove away. Johnson crossed the channel with the engine failing, the landing gear damaged, and more than 200 holes in the fuselage. When it landed at Manston, the ground staff counted as far as they could, then gave up recording each impact. The plane was destroyed, but in one piece. Johnson staggered out, covered in oil and soot. He just said, "She brought me back." The technical report would confirm what seemed impossible. 3 of the 4 main spars had been hit, the hydraulic system was lost, and part of the engine had been torn off. Even so, the P-47 remained flying. It was the first time the engineers realized they had built something beyond their own expectations. Word spread. In England, military newspapers nicknamed the plane the Juggernaut, the steamroller that wouldn't stop. Among the pilots, superstition was born. The Thunderbolt did not fall, it only descended when it wanted. And among the Germans, doubt began to arise. Intercepted reports from JG-26 recorded expressions of incredulity. No plane could withstand that. But the P-47 had endured, and in doing so, it broke something deeper than enemy steel. It broke the belief in German technical superiority. The irony of this story is that the solution was in front of them. Luftwaffe engineers obsessed with lightness and precision did not see that the real strength of modern warfare lay not in perfection, but in redundancy. The P-47 had layers upon layers of protection, duplicate systems, dual cables, extra shielding. What seemed like excess was actually planned survival, and this difference in philosophy began to erode German confidence. If you're enjoying unraveling these facts and seeing how engineering can become a destination, show your support. Like and subscribe. This helps us to continue to reveal the stories that changed the course of the war. After Johnson landed, the American command sent engineers to examine the plane. The confidential report concluded that the P-47 could continue to fly with up to 40% of the airframe damaged, an unprecedented figure. The radial engine withstood direct hits from explosive ammunition, and the cockpit armor protected the pilot from almost anything but a stroke of luck. Statistics began to confirm the myth. While the P-47 suffered casualty losses, their combat kill rates were incredibly low. In Europe, between April and September 1943, for every P-47 lost in combat, 3 enemy planes were destroyed. The Luftwaffe, until then confident, began to register an unsettling phenomenon. Missions against bombers protected by Thunderbolts were becoming lethal. Its 20mm guns, once deadly, seemed useless, and fear, invisible and corrosive, began to spread. When an enemy fighter flies back after being shot at 100 times, the enemy ceases to look human. It becomes inevitable. Johnson's case was studied for months. His superiors decorated him, but the real impact was in the hangars. Engineers redesigned structural reinforcements, adjusted the center of gravity, and turned that accident into a survival manual. The P-47 evolved not only as a machine, but as a concept. It was the first fighter built to win a war of attrition, not a duel between knights. In the months since, every American pilot who took to the skies over France knew what that aluminum shell represented. Not just firepower, but the promise of making it back alive. And that changed everything. Because a man who believes his plane can withstand anything fights otherwise. He fights without fear. Johnson's account crossed the Atlantic and reached German intelligence desks. The internal document of the Luftwaffe High Command, dated August 1943, recorded the doubt. Consistent reports indicate a new American aircraft of high structural strength, capable of absorbing multiple direct cannon hits. Check for the possibility of exaggeration. It was not an exaggeration. It was the harbinger of what was to come. The P-47, which in early 1943 was derided as a winged tractor, now became the weapon that defied the logic of aerial combat. From that day on, the sound of their propellers would stop causing laughter and would begin to cause silence. But the real transformation was yet to happen, because what the Germans saw as a miracle was, in fact, only the first demonstration of what American engineering could do when united with the industrial scale. And soon, those same wings that had defied fire would serve as a platform for a fury that would descend upon the fields and railroads of Germany like thunder itself. The secret of the P-47 Thunderbolt wasn't just in the courage of the pilots or the American industrial abundance, it was in the very logic with which it had been conceived. While German engineering extolled the refinement and elegance of forms, American engineering chose functional brutality. Alexander Kartveli, the engineer who designed the Thunderbolt, knew that the future of air warfare would not be won by thin wings, but by engines that would not stop. He completely ignored the European dogma of lightness and designed an airplane around an engine, not the other way around. At the center of its creation was the Pratt & Whitney R2800 Double Wasp, an 18-cylinder radial that produced more than 2,000 continuous horsepower, the toughest engine ever installed in a single-engine fighter. Unlike German inline engines, which were vulnerable to the first shot in the radiator, the R2800 could lose cylinders, leak oil, and still continue to run. The concept was simple and brutal, a plane that could catch up and keep flying. The real heart of the Thunderbolt, however, was behind the pilot, a system that the Germans didn't even fully understand. The turbo supercharger, a complex device that redirected exhaust gases to a rear turbine, compressing the air and returning it pressurized to the engine. This allowed the P-47 to maintain full power at altitudes where thin air caused enemy engines to die. While the Focke-Wulf 190 began to lose performance at 7,000 meters, the Thunderbolt still climbed, still roared, still hunted. By 1943, it was the only Allied fighter capable of maintaining 700 km/h at 9,000 meters. It was the power of American engineering transformed into an invisible tactical advantage, altitude as a shield, power as a weapon. The structure of the airplane was another chapter in American industrial logic. The P-47 was built as a flying tank. Its aluminum fuselage was made up of modular, easily replaceable sections. The control cables were double. The electrical system was redundant. The main fuel tank was below the cockpit, surrounded by steel armor and foam sealant, which prevented fires even after direct hits. This philosophy of total redundancy meant that the plane could withstand damage that would destroy any other fighter at the time. It was the opposite of the Messerschmitt Bf 109, whose structural delicacy made it a work of art and a disaster in maintenance. While the Germans built jewelry that broke, the Americans made tractors that killed. Each component of the P-47 reflected a pragmatic mindset. What was not essential to survival was discarded. What was vital was duplicated. Hydraulic systems had alternative paths. The manual controls allowed it to fly even with electrical failures. The pilot, protected by 90 kilograms of steel armor and thick glass, became the invulnerable core of a machine made not to give up. The Luftwaffe called this American excess. History would call it engineering to win. This philosophy extended to production. The P-47 wasn't handmade. It was assembled on assembly lines that operated 24/7. Every 55 minutes, a new Thunderbolt left one of the Republic or Curtiss factories. The airplane was not just a project, it was a multiplied idea. And each of them was almost identical to the other, which meant that parts could be swapped between models in the field. This allowed American mechanics to make repairs that, in the Luftwaffe, would have been considered impossible. A fighter hit in the morning could be back in the air by the afternoon of the same day. It was a war of efficiency against vanity. In the Allied maintenance camps, philosophical differences were visible even on the ground. The P-47 could land on dirt runways, operate in rain and mud, withstand overloads. Its wide landing gear, which many considered ugly, was the secret to safe landings in harsh conditions. The delicate German fighters, on the other hand, required prepared runways, specialized mechanics and scarce parts. When the war began to turn into a dispute of attrition, the P-47 showed its true purpose. It had not been created for perfect combat, but for constant combat. Firepower also reflected this doctrine of abundance. 850 caliber Browning M2 machine guns, 4 in each wing, offered a combined rate of fire of 7,200 rounds per minute. The total salvo of a P-47 released more than 13 kilograms of lead per second. For comparison, it was the same volume of fire as a light bomber. The machine guns, synchronized with industrial precision, created a zone of destruction so dense that it only took 2 seconds of firing to disintegrate an enemy plane. And as the P-47 plunged from altitude, the sound of 850s cutting through the air became the signature of a new era, the metallic thunder that the Germans would soon learn to fear. Meanwhile, the Luftwaffe continued to invest in technological refinements that required time, material, and skill. Each new model of FW-190 or Me-109 was a handmade variation, dependent on small workshops and manual adjustments. The United States, on the other hand, transformed ideas into numbers. The same principle that made refrigerators, tractors, and automobiles now produced warplanes. It was the triumph of method over pride. The irony is that American industrial strength itself had been born out of what the Germans despised: mass production. What was considered ordinary in Europe, soulless factories, serial products, became the engine of victory. Thunderbolt was the ultimate symbol of this mentality. Its heavy, uniform noise was not just the sound of an engine, it was the echo of an entire nation manufacturing power. This difference in mentality began to affect even the psychological of the combatants. American pilots, once suspicious, began to trust their machines more than their instincts. They knew that the P-47 could withstand what no other could withstand, and with that confidence, aggressiveness increased. The fear has subsided. It was the birth of the modern concept of air dominance, not to beat the enemy in every battle, but to make him unable to fight. The Germans still believed they were facing men, but now they faced systems. The P-47 was more than a fighter. It was the physical expression of America's ability to learn, adapt, and reproduce at scale. Every piece, every rivet, every propeller was a silent affirmation that the war had changed. Heaven no longer belonged to individual talent, but to the industry that sustained it. In November 1943, Adolf Galland, the Luftwaffe fighter general, wrote a sentence that summed up the new reality. "They don't stop coming. We knock down 5 and 10 appear, and when we hit them, they keep flying." It was a confession with no intention of weakness, but it was just that. The confession of an air empire that was beginning to understand that genius could not compete with persistence. But history had not yet revealed the full extent of this power. Because as the Germans tried to react in the skies, something much more devastating was beginning to happen on the ground. The P-47s were about to become not just plane hunters, but hunters of everything that moved under them. What began as a joke in April 1943 turned into a nightmare in the fall of that same year. The Luftwaffe, once absolute master of the skies of Europe, began to lose its own gods. Men who had accumulated more than 200 victories were shot down not by elite fighters, but by machines that, a few months earlier, had been called flying cows. The first shock came on October 8, 1943, at 28,000 feet over France. Lieutenant Colonel Hans Philipp, one of Germany's most decorated aces, a veteran of 500 missions and 206 victories, was leading his unit against a formation of B-17s, escorted by P-47s from the 56th Fighter Group. Philipp dove over the bombers with the confidence of someone who had survived it all. But as he crossed the sun, he found something he didn't expect. A wall of fire. The Thunderbolt, in a 30,000-foot dive, attacked with 8 50s at the same time. In 3 seconds, 360 shells tore through the sky. Philipp's Focke-Wulf exploded in mid-air, split into 2 halves. No parachutes were seen. It was the end of a myth and the beginning of the psychological collapse of the German airline elite. The tactic that destroyed Philipp had become a trademark of American pilots. The boom and zoom. They climbed to the operational limit, usually above 30,000 feet, and waited. When the enemy appeared, they dived like shells, accelerating to speeds the Germans could not even reach, firing in a single devastating pass before rising again. The P-47, with its weight and turbocharged engine, turned gravity into a weapon. The German fighters, lighter and with engines that suffocated at high altitudes, could not keep up. It was the complete inversion of the rules of aerial dueling. Whoever controlled the top controlled death. The Germans realized it too late. Their dogfight tactics, built on acrobatic maneuvers and instinct, became useless. Thunderbolt didn't play the same game. He didn't spin, he didn't dance, he just fell and destroyed. And when he climbed back, the Luftwaffe had no way to follow him. Every American dive was a sentence. In combats filmed by the gun cameras, the pattern could be seen: a short burst, a flash, and nothing remained. The P-47s transformed the sky into an industrialized firing range, where each attack followed an almost mathematical logic. The psychological impact on the German drivers was immediate. Major Wilhelm Galland, brother of the legendary Adolf Galland, died in circumstances almost identical to those of Philipp, shot down by a formation of thunderbolts over Normandy. His colleagues described the horror of watching the fighter disintegrate under the concentrated fire of 50 machine guns. The fragments went down in flames, and radio silence replaced the usual arrogance. When the combat report reached the high command, the reaction was incredulity. How could such a big, heavy plane maneuver so efficiently? The answer lay in physics. He didn't maneuver, he smashed. Over time, German fighter units began to reorganize, but the arithmetic of destruction had already changed. Each American pilot had more fuel, more flight time, more ammunition, and a plane that could be replaced in days. Each German pilot lost was an irreparable gap. Training had been curtailed by a shortage of resources, and rookies were pitted against American veterans with only 100 hours of flight time. It was an asymmetrical war disguised as a fair duel. Combat records show that from October 1943, the Luftwaffe's loss rate began to rise on an exponential curve. In just 3 months, the number of aces killed in combat exceeded the total of the previous 3 years. Invincibility dissolved in the face of a simple equation: power, altitude, and volume of fire. Major Walker Bud Mahurin, one of the first American aces, described the new style of combat coolly. "The secret is to strike like lightning, come down, destroy and disappear before they realize what has happened." This is how the P-47 earned its ultimate nickname among Germans, Donnerschlag, the thunderstrike. German reports began to reflect fear. Pilots reported attacks in which the sound of machine guns was compared to a thunderstorm. A lieutenant at JG-11 wrote, "They don't fire bursts, they dump rivers of metal." The phrase, "American lead," has become synonymous with condemnation. In a few seconds, what was once arrogance turned into superstition. Experienced pilots avoided high-altitude combat. Some even asked to be transferred to anti-aircraft defense units, judging it safer to face bombers than to face the roar of the P-47s. The technical imbalance grew. While the BMW 801 engine of the FW-190 suffered a loss of power above 7,500 meters, the Pratt & Whitney R2800 of the Thunderbolt maintained full performance up to 9,000. This meant that the American could choose when and where to fight. Battles are no longer about reflections and have become about energy. The P-47 was a weapon that accumulated energy in diving and converted it into a lethal advantage. The enemy only realized the attack at the moment when it was too late. The German moral collapse became visible in the statistics. In 1943, for every American pilot shot down, the Luftwaffe lost 4. In 1944, this ratio would jump to 7. The skies that once echoed the triumphal singing of individual aces now resounded with the mechanical sound of serial production. The myth of skill has been replaced by the terror of efficiency. The Luftwaffe still had brilliant pilots, but the war was no longer about brilliance, it was about permanence. Meanwhile, the United States continued to produce P-47s at an increasing pace. The same model that destroyed fighters at altitude was adapted to carry bombs, rockets, and fuel tanks. Each new modification widened the gap between philosophy and reality. For Americans, the Thunderbolt wasn't just a fighter, it was a combat system. For the Germans, it was the harbinger of an era in which the pilot ceased to be an artist and became a machine operator. In December 1943, an internal Luftwaffe document acknowledged the change. "The enemy does not fight as we do. It employs mass force and high-strength apparatus. Our doctrine no longer applies." It was the prelude to a defeat that was drawn not in tactics, but in mentality. The duel between the engineer and the pilot was over, and the engineer had won. In the following months, the sound of the P-47s over France would become routine. German ground troops learned to recognize it from afar, a deep roar that preceded destruction. And when Luftwaffe fighters tried to intercept, they found themselves facing an adversary that already dominated the battlefield. But the real terror was yet to come, because the Thunderbolt, which had conquered the sky, was about to turn its fury to the ground and turn the continent itself into a field of fire. American doctrine quickly learned that the P-47 was not to be treated as a Spitfire. It required a combat grammar of its own, and from that, learning was born a tactic that would invert all expectations: rise, converge, dive, and punish. The American formations began to operate in layers of energy, seeking altitude as a primary advantage. Instead of seeking the encounter face-to-face, the Thunderbolt pilot would accumulate potential at height, wait for the right moment, and then converge on the enemy with speed and mass, turning potential energy into kinetic destruction. This principle, which the instructors called boom and zoom, turned apparent disadvantage, weight, lack of agility and sharp turns, into a decisive weapon. The P-47 climbed where the Messerschmitt and Focke-Wulf choked. The altitude became a fortress. The formation maintained discipline. Climb together, execute a single and lethal pass, recover energy and repeat. It was a tactic of patience and precision, not of aerial vanity. Each dive was calculated to maximize the convergence of the 850 caliber machine guns, creating a concentration zone where the probability of hit reached numbers that the German pilots had never faced. In practice, the American did not try to win a fight. He tried to prevent the fight from even taking shape. Physics was on the side of the Thunderbolt. The weight that made the aircraft ridiculous in maneuver favored the ability to sustain energy in a dive, and consequently to recover and escape before the adversary could react. At the same time, American industrial power held to this doctrine. Abundant ammunition, fuel tanks, spare parts, and flight lines full of new Thunderbolts allowed pilots to adopt the tactic without the terror of replacement. Missing cost less because the machine could return. The boom and zoom was ultimately the tactical application of a major logistical advantage. While the German pilot was instructed to take care of his aim and economy, the American could trust that if he survived, there would always be more iron and fuel waiting for him. American formations learned to operate like a hammer that fell repeatedly on a nail, each fall measured and definitive. In practice, when a formation of P-47s encountered a group of German fighters below, the maneuver was almost ritualistic. Go up, see, choose the target of opportunity, dive with weight stabilization, unleash a concentrated 50s burst at the point of convergence and leave. The enemy often did not even have time to understand what had happened. The tactical effectiveness was evident in the footage from the onboard cameras. In mere fractions of a second, the impact was almost tetrahedral. Fire, fragmentation, loss of control surfaces, disintegration. For the German driver, accustomed to technical dueling, the shock was psychological. How to react to a force that behaved like a physical phenomenon and not like a human opponent. The American adaptation was geometric. Training, flight rules, maintenance instructions and field modifications transformed a collection of heavy aircraft into a standardized instrument of attack. Gun convergence tables, recommended dive angles, optimum altitudes and recovery times were distributed and practiced as a trade. Engineering also played a role. More efficient blade propellers, center of gravity adjustments, and engine cooling improvements allowed the P-47 to maintain control at speeds that had previously seemed fatal. The combination of tactical discipline and technical refinement created a synergy that, over European theater, proved devastating. Meanwhile, the Germans, whose tactics grew out of individual experience and improvisational campaigning, watched with increasing bewilderment as their best units were decimated by short, accurate, and brutal passes. The contrast was both cultural and technical. On the one hand, the methodical application of resources and science. On the other, the art of the pilot, vulnerable to mathematics. In a change that only those who analyzed numbers could predict, the tactic converged with the industry in an almost inevitable result. The Thunderbolt's mission departure kill rate began to exceed expectations, and the cost per loss to the Allies became manageable in the face of the continuous replacement of trained aircraft and pilots. It is worth pausing for a fact that punctuates this gap in perception, and that the Germans, out of doctrinal pride, simply ignored. At the peak of production, the United States delivered more than 10 times the tonnage of planes and components compared to Germany's specialized production capacity in the equivalent period. If this number is surprising, write in the comments with one word: absolute power, unbelievable, shocking data, or logistics wins. This is the economy of combat. When industrial mathematics enters the field, the isolated tactic loses its primacy. The tactical consequence was immediate and brutal. German patrols, accustomed to looking for opportunities in duels of skill, began to avoid direct contact with high-level American formations. Pilots who had previously hunted Spitfires felt for the first time that they were the target of a policy of systematic extermination. The noise of the P-47's propeller blades, now associated with the diving passes, became an indicator of imminent danger. the so-called Donnerschlag that men ashore had come to fear. Over time, the presence of the Thunderbolts in battle regions altered the enemy's freedom of movement. Railway convoys were attacked with impunity, concentrations of equipment became priority targets, and German ground forces found that the protection that the sky had guaranteed them since 1939 evaporated in the presence of the new American tactical instrument. War was no longer just a game of pilots. It became space and access control, and the P-47 was the key to that control. In the human sphere, change has also manifested itself. American pilots have gained confidence and aggressiveness. German morale in turn began to waver. The pilot who once boasted of his skill now had to calculate risk and recognize that the Thunderbolt's fire button represented a sentence when physics was favorable. And it wasn't just the quantity of fire, it was the quality of convergence. 8 synchronized 50s, armor-piercing incendiary ammunition, and the firing range calculated to maximize hit probability. In combat, all of this added up to a new factor of lethality. Finally, the tactical adaptation of the Thunderbolt inaugurated a principle that would permanently change air warfare. Supremacy was no longer guaranteed by individual glories, but by the ability to project force repeatedly and over long distances. The P-47, conceived as a flying fortress, became the technical expression of this idea. And as the Luftwaffe retreated to reassess its beliefs, a question hung over the German command desks: how to confront a force that had turned altitude and weight into a decisive advantage. The answer, however, wouldn't come from the clouds. It would come from the production lines, where numbers and steel were bracing for an impact that had just begun. By the end of 1943, the war in the skies of Europe was no longer fought between men. It was fought between factories. The Reich still relied on its air aristocracy, men forged in flight academies, and trained under the belief that individual talent would decide the fate of battles. But the world had changed. The United States had turned combat into an industrial phenomenon. Each time one P-47 crashed over France, another left the assembly line at Farmingdale, Long Island. The average time between a combat loss and the replacement of the aircraft was 4 days. In Germany, this cycle could take months, and sometimes it never did. It was the collapse of the equation that sustained the Luftwaffe's pride. There was no longer a ratio between effort and result. For every American pilot shot down, 10 new ones were being formed. For every plane lost, 20 were being assembled, and each of them bore the same metallic roar as the R-2800 engine, mass-produced with millimeter precision by workers who had never seen the battlefield. By 1944, American production had reached numbers that seemed absurd even to its own commanders. The Republic Aviation and Curtiss Wright factories produced more than 500 P-47s a month. Each unit required 65,000 pieces, 8 miles of electrical wires, and 300 pounds of rubber. Aluminum flowed from the smelters like the blood of a war economy in full swing. The double Wasp engine alone required 2,400 components, machined to tolerances of thousandths of an inch. But what was impressive was not the complexity, it was the repetition. While Germany struggled to build high-performance fighters like the FW-190D and Me-262 in small series, America treated planes as line products. It was the industrialization of the sky. The Luftwaffe, on the other hand, was suffocated. German production of fighters in 1943 was lower than the monthly production of American training aircraft. Aluminum became scarce, fuel was rationed, and the number of trained pilots plummeted. The average training time for a new German aviator had fallen to less than 120 flight hours, a third of what was required at the start of the war. In the United States, the training centers operated on a continental scale. In 1944 alone, more than 30,000 fighter pilots completed their advanced courses. Each of them flew simulators, practiced live shooting, studied instrument navigation, and underwent technical instructions on engines and ballistics. The difference wasn't just in the quantity, it was in the depth. The new American pilot was not an improvisation. It was a planned, standardized, and multiplied product. The effects of this disproportion began to manifest themselves on the battlefield. The Luftwaffe's high command watched helplessly as its ranks eroded. In January 1944, General Adolf Galland reported to Aviation Minister Hermann Göring that the losses had become statistically unsustainable. The words statistics and war had never coexisted so well. The Americans were winning by table, and each number represented a cog in the German collapse. Allied factories, protected by geography and fueled by Texan oil and Caribbean bauxite mines, operated day and night. While B-17 bombers hit the Reich's production lines, Liberty ships unloaded tons of engines, ammunition, and spare parts into England. The arsenal of democracy, as Roosevelt had called it, had become the decisive weapon. Each Thunderbolt that crossed the Atlantic brought not only an engine, but the demonstration of a concept. The war could be won with statistics. The 9th Air Force, equipped almost entirely with P-47s, consumed more than 25 million gallons of fuel a month, and every drop arrived via protected sea lanes, transported on tankers built at a rate of 1 a day. On the other hand, the Luftwaffe began to lose more planes due to lack of fuel than to enemy action. The fighters stayed on the ground, and the pilots, demoralized, watched the skies being occupied by the constant sound of American propellers. The cultural difference became visible even in the language. For the Germans, air warfare was an art of precision. For the Americans, it was a logistical operation. When a group of fighters returned to base after a mission, engineers and mechanics were already waiting with tools, fuel and ammunition for the next flight. The average time between landing and takeoff again was 40 minutes. The Luftwaffe, for its part, took up to 6 hours to rearm and overhaul its fighters, and there were often not enough parts to do so. This difference in pace was invisible on the maps, but deadly in the air. Allied intelligence reports accurately noted the degradation of the enemy. By 1944, the replacement rate of German pilots was less than 40% of monthly losses. The hasty training produced men who barely knew how to handle the oxygen system, and many died before completing a mission. The sky, which had once been the domain of knights, had become a production line of death. The P-47 now didn't just represent a machine, it represented an idea that strength isn't in art, but in the ability to reproduce art infinitely. American factories worked with an almost ritual cadence. In Evansville, Indiana, women and teenagers riveted their wings under the constant noise of hydraulic presses. Each rivet was part of a system that converted civilians into empire builders. The very aesthetics of war had changed. While Germany depended on renowned engineers and refined techniques, the United States depended on processes, spreadsheets, automatic conveyors. Perfection is no longer the goal. Volume is now victory, and the results were inescapable. Between 1943 and 1945, the United States produced 15,783 Thunderbolts. Germany, in the same period, managed only 5,600 Focke-Wulfs from the A series. They couldn't replace what they were losing. The Reich wasn't being defeated on the battlefield, it was being drowned in steel. In August 1944, a British intelligence report concluded that the Luftwaffe had ceased to exist as an independent strategic force. Scattered squadrons remained, many of them without enough fuel to take off. Veteran pilots were required to teach recruits who had never fired a gun in flight. It was the end of the myth of tactical supremacy. Air warfare, once a poetry of speed and maneuver, had been transformed into industrial prose. But the ultimate symbol of this change was yet to come. The P-47, born as a high-altitude interceptor, was about to descend, literally, and take the war to the ground. The thunder that had destroyed the skies of Germany would now begin to fall on its roads, trains, and tanks. And what the Germans would call terror from the ground would begin with the same sound they had despised a year earlier, the deep roar of the supersonic blades of an American plane. On August 17, 1943, the Bavarian sky became the laboratory where the future of modern warfare would be tested. The combined operation over the cities of Schweinfurt and Regensburg represented the first Allied attempt to reach the industrial heart of the Reich in broad daylight. It was an insane gamble. 376 B-17 Flying Fortress bombers would penetrate deep into Germany without complete cover to attack the ball-bearing and aircraft assembly factories, vital targets for the arms industry. The Luftwaffe, alerted by the scale of the incursion, prepared a colossal interception. Hundreds of fighters, among them the best available FW-190 and Bf-109, took off to defend what was left of German technological pride. It was the day when the whole sky seemed to vibrate with the collision of two worlds, one driven by artisanal genius, the other by the brute force of industry. Among them, as a wall and hammer, were the P-47 Thunderbolts. The Thunderbolts of the 56th and 78th Fighter Groups were ordered to advance to the range limit, 300 kilometers inside Germany, to cover the first phase of the mission. They rose in dense formation, the glow of the aluminum reflecting off the summer sun as the bombers trudged toward Regensburg. In front of them, the Luftwaffe prepared the ambush. The Germans believed they knew the enemy. They knew that American fighters were heavy, slow to climb, and vulnerable in turns. What they did not know was that on that day, they would discover the difference between concentrated fire and total fire. As the first group of Messerschmitts emerged from the clouds, plunging over the B-17s, the Thunderbolts reversed position, falling from 25,000 feet with roaring engines and the 8 Browning machine guns spitting out a solid curtain of metal. The sky exploded. The accounts of the German pilots describe something almost supernatural. Hans Ulrich Rudel, watching from a nearby fighter, wrote that he seemed to look at hammers hitting the very atmosphere. Each P-47 released more than 3,000 shells per pass, a burst dense enough to cut a wing in seconds. A Luftwaffe gunner, a survivor of the massacre, reported that a Messerschmitt simply dissolved as if struck by a hammer of God. Accuracy came not from perfect aiming, but from the meticulously calculated convergence of the weapons. The space between 250 and 400 meters became a lethal zone where anything that entered ceased to exist. The numbers counted for the rest. In less than 20 minutes of combat, 24 German fighters were shot down, an absolute record for a single day of interceptions. And for the first time, the Luftwaffe understood that the problem was not just tactical, it was structural. Each Thunderbolt carried enough ammunition for 30 continuous seconds of firing, an eternity in the air. Each of those bullets was mass-produced in factories such as Lake City Ordnance, Missouri, which produced 30 million rounds a month. Germany, with its manual workshops and collapsed logistics chains, could not compete. The combat of Schweinfurt-Regensburg revealed an uncomfortable truth. The Luftwaffe's doctrine had been designed for gentlemen's wars, but now faced a winged production line. The scene on the air was almost biblical. The B-17s continued to move forward, slow and heavy, while the Thunderbolts descended on the interceptors like cascading thunder. The 50 bursts opened tunnels of smoke and metal fragments. The sound of supersonic blades cut through the wind like the harbinger of disaster. In a moment recorded on the onboard cameras, a P-47 of the 62nd Squadron dove directly over a group of Bf-110s, twin-engine fighters assigned to attack the bombers, and opened fire at 300 meters. One of the Germans simply exploded, another lost its wings instantly, and the third spiraled off to the ground. The surviving gunner, Fritz Roth, would later say, "The American fighter descended like a hammer from the sky. I shot first, we hit his wing. The P-47 didn't even wobble. Then he shot, and our plane ceased to exist." This testimony would be used in American intelligence reports to illustrate the psychological impact of Browning machine guns. The combined strength of the 8 guns was equivalent to the fire weight of an entire platoon of infantry. Each second of firing released about 8 kilograms of metal, heated to almost 1,000 degrees, traveling at 850 meters per second. It was destruction on an industrial scale translated into seconds, and each American plane carried thousands of these munitions, while the Germans were already rationing projectiles. The struggle was no longer balanced, it was pure mathematics. Allied losses were heavy. 60 bombers did not return, but the impact on the Luftwaffe was catastrophic. More than 300 fighters were destroyed or damaged. Worse, the Germans realized that the air war had crossed a point of no return. Its best pilots were dead, and their undertrained replacements faced an enemy who could afford to lose and keep going. Oberst Hannes Trautloft, one of the Luftwaffe's most respected commanders, wrote in his diary after the battle, "They fight with factories. We fought with courage, and factories are more numerous." The next day, as engineers assessed the wreckage, the contrast between the machines was stark. The fuselages of the FW-190s looked flimsy next to the captured Thunderbolts. American aluminum with a thicker alloy will resist multiple impacts. The radial engine, practically intact, could be reassembled and used again. The P-47 was more than an airplane. It was a product designed to withstand wear and tear. The Luftwaffe was beginning to understand that the battle was no longer between wings, but between assembly lines. In the German High Command, Hermann Göring reacted with fury to the news. He called his generals incompetent and accused them of losing their grip on the heavens. But the truth was deeper. No one could win a war in which the enemy could make planes faster than they could shoot them down. The Battle of Schweinfurt and Regensburg was not just a military confrontation, it was the epitaph of a philosophy. The duel between skill and production had been decided. When the last Thunderbolt returned to England, covered in holes but still in one piece, the pilots realized that something had changed forever. From that day on, they weren't just fighting for victory, they were fighting for confirmation of one fact: America could build power faster than the world could resist. And the thunder, which until then had sounded distant, began to become permanent. For soon, far beyond the skies of Bavaria, it would descend upon the roads, the tanks, and the very foundations of the Reich, and then the ground of Europe would begin to shake. In early 1944, the European front began to live with a new sound, a sound that preceded the end. At first, it was just a distant, low, continuous noise, like the echo of an approaching storm. But German soldiers soon learned to recognize it. The roar of the wide blades of the P-47 Thunderbolt's Pratt & Whitney R2800 engine. The vibrations were so strong that they could be felt on the ground seconds before the plane appeared on the horizon. The troops called it Donnerschlag, the blow of thunder. It was the name given not by official order, but by spontaneous fear. The thunder was not seen, only heard, and when the sound grew, they knew it was too late to run. In the fields of Normandy, on the roads of France, and in the valleys of Belgium, the noise of the American radial engine became synonymous with sentence. The sound of an airplane that the Luftwaffe had despised was now turned into legend and dread. German pilots, who had previously laughed at the Thunderbolt's heavy silhouette, began to identify it not by sight, but by sound. The roar of the radial engine was unique, low, jagged, vibrant, different from the high-pitched whistling of the inline engines of its own fighters. When the Donnerschlag echoed in the clouds, there was no doubt. It was a P-47 in dive, and within seconds the sky was filled with fire. The attack began even before the first shot. The sound of the blades cutting through the air at supersonic speeds produced a characteristic howl, a metallic scream that made men throw themselves to the ground out of reflex. Reports from Wehrmacht soldiers describe entire rows interrupting marches, as if discipline itself had surrendered to instinct. When the thunder came, we knew that someone was going to die, wrote a non-commissioned officer of the German 12th Army in a letter intercepted in 1944. The psychological phenomenon was so striking that officers began recording the sound effect in combat reports. Major Karl-Heinz Brendel, commander of an anti-aircraft battery, noted, "The troops are paralyzed when they hear the sound. Even without the enemy's visuals, the noise causes panic. They call it American thunder." Industrial warfare had created something that aviation tactics had never produced, a sonic symbol of power. It was no longer a matter of seeing the adversary, it was a matter of feeling him coming. The sound of the P-47's engine was the harbinger of a force that, for the German soldier, came from another world. This psychological effect was not accidental, it was a direct result of engineering. The P-47D had introduced a Hamilton standard four-bladed wide propeller designed to convert the engine's monstrous torque into efficient thrust at low altitudes. But the side effect was acoustic. The huge diameter and tips of the blades, which exceeded the sound barrier in dives, created sound shock waves audible from miles away. It was literal thunder. Each pass left a trace of pressure in the air, a deep rumble followed by the metallic roar of machine guns. The airplane had become, unwittingly, an instrument of psychological warfare. On French roads and in the Belgian countryside, sound preceded destruction. The P-47, once limited to escort, now dove over columns of tanks, trucks, and trains. From its fuselage descended 500-pound bombs and 5-inch rockets. The impact was total. Panzer divisions, which had once advanced with confidence, now moved only under night cover. The sound of the radial engine during the day was enough to disperse entire speakers. It was as if the sky itself had chosen a side, recorded a survivor of the 9th Panzer Division, describing the attack on an armored column in Belgium. The sound started as a whisper, and then it turned into a scream. The ground shook before we saw anything. When I looked up, we were already burning. For the Allies, the Donnerschlag became a tool of psychological domination. Units of the 9th Air Force began to conduct intimidation flights, low-flying passages without weapons, only to generate the noise that forced the enemy to disperse. The mere auditory presence of Thunderbolt was enough to interrupt movements and delay reinforcements. For the first time, sound was a strategic weapon. Industrial warfare had created its own roar, and that roar destroyed more than tanks. It destroyed morale. Among pilots, the P-47's reputation was growing as a myth. Bomber crews called him the Angel of Thunder. The ground forces saw him as a protective entity that roared before falling on the enemy. On the other hand, for the Germans, thunder had become an omen. On campaign radios, the code Donner kommt, the thunder comes, began to replace conventional warning messages. The commanders themselves began to report difficulties in maintaining discipline when the sound appeared on the horizon. Oberst Dietrich Peltz, air operations planner for the Luftwaffe, wrote, "We no longer just fight planes, we fight their sound." This reversal of perception marked the definitive transition from the Romantic War to the Industrial War. Before, the enemy was a silhouette, a distant figure in the sky. Now, it was a frequency. Germany, which had always believed in the technical heroism of its aces, found itself powerless in the face of a machine that did not need to be seen to inspire fear. The P-47 wasn't just a fighter, it was a sound signature, a constant presence. The arrogance that had made pilots laugh at his size now turned into superstition. That metallic sound, half motor, half thunder, came to be interpreted as the echo of an inevitable force. The psychological effects extended to German air bases. Technicians and mechanics reported insomnia and nervousness from hearing the constant noise of American engines during night patrols. Repair factories began to be abandoned in a hurry in the face of rumors of the thunder approaching. Even when the attacks came from other planes, the victims swore they heard the sound of the P-47. Fear had become omnipresent and sound omnipotent. In March 1944, the Luftwaffe Intelligence Service prepared a confidential report with a revealing title, Psychologische Wirkung des P-47 Thunderbolt auf das Bodenpersonal. Psychological effect of the P-47 Thunderbolt on ground personnel. The document officially acknowledged that the noise of the plane caused panicked reactions and disorderly flight among the troops. The text ended with a sentence that summed up the German cultural defeat: "The enemy has built a sound that we cannot silence." By this point, the Donnerschlag had already become more than a weapon. It was a symbol. It represented the embodiment of American industrial power, the idea that an entire nation could turn aluminum and noise into domination. The sound that once made the Germans laugh now made them pray, and the war, which had begun as a contest of engineers and pilots, had turned into a symphony of machines. But the real devastation was yet to come, because the thunder, which was already making the sky tremble, was about to descend on the ground for good. And when the P-47 turned its fury against the tracks, tanks and columns of the Wehrmacht, Germany discovered that the sound of the Donnerschlag was not the end of the storm. It was just the warning that it was coming. By mid-1944, the P-47 Thunderbolt had definitively abandoned the elegance of fighter duels and plunged into what would define modern warfare: the systematic destruction of the enemy on the ground. It was the birth of the Fire Age. The plane that had been designed to hunt other planes now hunted everything: tanks, trucks, trains, bridges, infantry columns, depots, and even supply horses. The U.S. Air Force realized that it possessed an attack tool so powerful and resilient that it could be used to shape the battlefield. And what was once just distant thunder became a permanent storm over the German army. In July 1944, during the offensive at St. Lo, 1832 P-47s simultaneously attacked German positions. Within hours, 2,000 tons of bombs and 5,000 rockets turned the terrain into smoldering craters. The sky roared, the ground shook, and the Reich discovered what it meant to face America's industrial fury. The success of this new phase was not improvised. It was the direct result of the engineering and logistics that underpinned the American machine. The P-47D, in the Razorback and later in the bubble-top version, could carry up to 1,000 kilograms of bombs, as well as 5-inch rockets and supplementary fuel tanks. No single engine fighter in the world could support so much weight without losing stability. While the Spitfires and Messerschmitts could barely carry 2 light bombs, the Thunderbolt set out on the mission with the equivalent weight of a light bomber, keeping its armor intact. The secret was in the structure: wings reinforced with duralumin stringers and a wide landing gear, designed to absorb impact on uneven terrain. The aircraft could land on makeshift dirt runways, refuel in minutes, and return to the attack. It was the perfect cycle of a machine built for repetition. From the Normandy landings, the sound of the R-2800 engine became ubiquitous. The entire front lived under the shadow of the Jabos, German abbreviation for Jagdbomber, the fighter bomber. The columns of the Wehrmacht moved only at night. During the day, any movement was suicide. A report from the 2nd Panzer Army described the scene. The Americans dominate the sky. Your planes appear out of nowhere. Within seconds, everything is on fire. Our tanks become furnaces. The P-47 attacked in 45-degree dives, dropping bombs with surgical precision and ending the attack with bursts from the 850 machine guns. A single airplane could sweep an entire road. The crews called it line cleaning. German soldiers called it der Höllenhammer, the hammer of hell. By August, Allied intelligence reports showed that the Thunderbolt's firepower had reached an unprecedented scale. In the 6 weeks after D-Day alone, P-47s destroyed 6,000 vehicles, 3,000 locomotives, and hundreds of tanks. For each missed flight, dozens of targets were eliminated. The Luftwaffe could not react. Its pilots, low on fuel and without air superiority, found themselves reduced to targets on their own territory. Hitler's command ordered the supply columns to be camouflaged, painted green, hidden under trees. But nothing stopped the Jabos. The P-47's engine could be heard before it was seen, and the sound was enough to spread panic. In letters intercepted by the British Secret Service, German soldiers described the Thunderbolt's passages as the end of the world. The war had become an industrial operation in every sense. To sustain the attacks, the American forward bases in France functioned as mobile factories. Tanker trucks fueled the planes directly on the dirt runways, and ammunition trucks unloaded thousands of 50 rounds and M8 rockets produced continuously in the United States. The cadence was mechanical. Each P-47 landed, received fuel, bombs, and ammunition, and took off again in less than 30 minutes. It was war transformed into an assembly line. At this point, the contrast between the two philosophies, German artisanal precision and American mass production, reached its apex. The enemy still tried to fight with refined pieces, but the opponent fought with absurd quantities, and the numbers spoke louder than any myth. The U.S. Air Force maintained 20,000 operational fighters in Europe, the Luftwaffe less than 3,000. The Americans manufactured 8,000 airplane engines per month, the Germans 700. When one Thunderbolt crashed, another was already flying before the enemy could celebrate. If this difference seems incomprehensible, write down this number. In 1944, American production of aerial munitions was 15 times greater than Germany's. And if this impresses you, comment below with one word: absolute power, unbelievable, or logistics wins. Because that's exactly what logistics turned the P-47 into a divine weapon. Tactics have also evolved. With ground forces advancing, pilots began operating in pairs, assigning one plane to mark the target and another to execute the attack. Radio communication allowed precise coordination with troops on the ground, something unthinkable for the Germans, who still relied on visual flares. American doctrine called this tactical interdiction, cutting the enemy's arteries before the heartbeat. Railway lines, bridges, and depots have become priority targets. Each successful mission was a logistical amputation of the German army. The P-47 was no longer just a combat aircraft. It became the scalpel of modern destruction. The human impact of this new phase was devastating. On French roads, entire columns of civilian and military vehicles were decimated. The survivors described dantesque scenes: overturned trucks, charred men, tanks melting under the heat of the incendiary bombs. A captured German lieutenant summed up the feeling: "We no longer fight soldiers, we fight machines that come from the sky." The war of honor, of dueling and bravery, had died. In its place, the era of absolute efficiency had arisen. Even allies began to realize the symbolic weight of Thunderbolt. Among American troops, it was seen as an omen of victory. The land columns knew that as long as the thunder roared above them, victory continued to advance. For the Germans, it was the opposite. The sound of the P-47 marked the beginning of chaos. The Donnerschlag had become the prelude to the collapse. American air supremacy had been transformed into total dominance, a combination of metal, industry, and method. By the autumn of 1944, with the Reich in retreat, the Thunderbolt had ceased to be just an airplane. It was the symbol of a mechanized civilization, proof that war no longer belonged to geniuses, but to gears. And when the German divisions tried to fight back with their last heavy tanks, believing that armor could still save them, They discovered the P-47's last secret, its power to destroy even steel. Because the next phase of thunder would not come from above. It would come in a straight line at low altitude, with rockets passing through the panzer turrets like fire spears. June 6, 1944. The dawn over the English Channel didn't just bring light, it brought the deafening sound of supremacy. At 5 a.m., the collective roar of more than 500 P-47 Thunderbolts formed a wall of sound over the waters, covering the horizon with metal and thunder. It was the prelude to the invasion of Normandy, the largest military operation in history. As Allied ships poured men and tanks onto the beaches of Omaha, Utah, Gold, Juneau, and Sword, the sky already belonged to the Americans. The fighter bombers patrolled in synchronized blocks, with almost industrial precision. Each group controlled one airstrip, each minute of timed flight. The order was clear. Nothing German should move, neither in the air nor on the ground. The P-47 was no longer a technological promise. It was a living cog in the machine of liberation. What began in 1943 as a ridiculed airplane now underpinned the offensive that would change the world. The first German fighters tried to react. At 0720, a formation of FW-190s from Jagdgeschwader 2 was detected, attempting to intercept bombers covering the beaches. They didn't even get to see the sea. The Thunderbolts plunged from 25,000 feet with the sun at their backs, and within seconds, 5 German fighters were destroyed. The rest dispersed. Oberleutnant Wolfgang Fischer, one of the 3 pilots who survived, later reported, "There was no combat, only instant death. The sky was theirs, at all altitudes." American dominance was so absolute that Luftwaffe units began to be ordered to avoid direct confrontation, but the war did not wait for them. As the Allied armies advanced along the beaches, the P-47s continued to do what they knew best, destroy everything that sustained the enemy. D-Day was the pinnacle of Thunderbolt's transformation into a saturation weapon. With his 500-pound bombs and 5-inch rockets, he dived over artillery positions, coastal fortifications and reinforcement columns. Each attack was a demonstration of coordination and power. The 50 machine guns swept trenches, cut telephone wires, set fire to trucks. The metallic noise of Hamilton's standard wide blades echoed through the valleys of Normandy, a sound German troops called the Song of Death. The psychological impact was devastating. Many German soldiers surrendered without even seeing an Allied soldier. The sound in the sky was enough. General Hans Speidel, Chief of Staff of Army Group B, wrote in his diary, "The troops do not fear the enemy they see, but what they hear. The thunder is constant. Courage evaporates before combat." Meanwhile, at temporary air bases in England, American efficiency worked like an endless assembly line. The 9th Air Corps refueled and armed hundreds of P-47s simultaneously. On average, each plane flew 3 missions per day. The ground crews operated like mechanical surgeons. 15 minutes for fuel, 20 for ammunition, 10 for engine checks. The result was a cadence that the Luftwaffe could not even imagine. On that June 6th, the P-47s completed 1,168 sorties, an average of 1 takeoff every 30 seconds throughout the day. No air force in history had operated with such timing. On the other side of the front, the Luftwaffe barely existed. Of the approximately 400 fighters available in northwestern France, fewer than 100 managed to take off. Most were destroyed on the ground by preliminary shelling. The lack of fuel, pilots, and central command had made any organized resistance impossible. In contrast, the Allied command had 12,000 aircraft ready to go into action. The ratio was 30-1. The air war had ceased to be a duel. It had become an execution. The irony was total. The plane that Germany had called a flying milk bottle was now the guardian of the operation that would seal the fate of the Reich. As the day progressed, the P-47s widened the radius of destruction. Every road, bridge, and train track within 50 kilometers of the beaches was attacked. The Germans tried to move reinforcements through the night, but the next dawn brought the same thunder. The attack on the Perrier Bridge was a classic example. 4 P-47s dived in sequence, destroying the crossing point with a precision that seemed surgical. The German engineering officer in charge of the repair described the result in his report. The bridge was not hit, it was erased. That was the new vocabulary of American war. Erase, not just destroy. The Allied accounts of D-Day highlight not only the physical impact, but the symbolic one. General Eisenhower declared that without air dominance, the landing would have been impossible. The domain, however, had a face and a sound, the P-47. With each dive, he swept away the resistance. With each climb, he left behind columns of smoke and silence. The war had turned into applied engineering. It was the victory of statistics over courage. On the afternoon of the 6th, an episode synthesized this new reality. A German squadron attempted to reach the beaches of Omaha from the interior. 12 FW-190 fighters were sighted at 5,000 feet. American Captain Walker Mahurin led the charge. In less than 3 minutes, everyone had been shot down. No German pilot managed to fire a shot. The American report summed it up in a cold sentence. Contact made at 4:21 p.m. No enemy left at 4:24 p.m. It was the perfect portrait of a war decided before it began. As Sherman tanks advanced through the dunes and ships continued to dump men into the sand, the P-47s maintained absolute air dominance. They didn't just protect the landing, they shaped the battlefield in real time. The sky, which for years had been the domain of German aces, had become the territory of American industry. The Luftwaffe, once Germany's technological pride, was reduced to echoes of the past. General Adolf Galland would confess after the war, "In Normandy we realized that the war was over. The enemy didn't just have planes, they had a factory in the sky. By the end of the day, when the clouds covered the channel again, the sounds of the blades and engines became more spaced, but the echo remained. It was the sound of the definitive turn of history. The American thunder, once a laughingstock, had become the soundtrack to the liberation of Europe." And as the pilots returned to base covered in soot and smoke, they knew that this was just the beginning, because what would come next would not be a battle. It would be a hunt, a war waged no longer against organized armies, but against the enemy's own nerves and morale. Thunder didn't just dominate the sky, now he descended to rule the earth. By 1944, war was no longer just fought in the skies or in the trenches, it was fought on the assembly lines. In the United States, as the Thunderbolts roared over Normandy and burning France thousands of miles ago, another front operated in metallic silence. Republic Aviation's factories in Farmingdale, Long Island, and Evansville, Indiana. It was there that the real miracle happened. In its immense corridors, lit by fluorescent lamps and filled with the constant sound of riveting machines, presses, and engines, America did the impossible. It completed a P-47 Thunderbolt every hour. It was not a figure of speech. 60 minutes were enough for a structure of aluminum, wires, cables, and steel to become one of the most lethal war machines ever created. It was the triumph of engineering and industrial coordination, the transformation of the economy into an army. Each Thunderbolt required 65,000 individual parts. The Pratt & Whitney R2800 engine alone comprised 2,400 machined components with tolerances measured in thousandths of an inch. The wings contained 8 miles of electrical wiring. The frontal armor was made of 3-tar 8-inch tempered steel, and the windshield was made of half-inch ballistic glass. No detail was handmade. Everything was standardized, calculated, replaceable. Republic Aviation had turned the concept of mass production into military doctrine. What was once Ford's secret to making automobiles now became the basis for producing air power. And the result was what the Luftwaffe feared most: quantity with quality. As the Germans struggled to assemble a few hundred Me-109 and FW-190 fighters a month, American assembly lines dumped thousands of P-47s. The Evansville plant, erected in a former agricultural field, produced 500 aircraft a month. In that same period, all of Germany was able to produce just over 800 fighters nationwide, and lost almost that number every month. The difference was not only in the numbers, but in the philosophy. The Germans were still stuck with the idea that the war could be won with innovation and bravery. The Americans had understood that victory depended on pace. Modern warfare was a matter of replacement, and no one replaced it faster than the United States. The impact of this industrial machine was directly reflected on the battlefield. An American squadron could lose 20 Thunderbolts in a day and receive 30 replacements in a week. The German pilot shooting down a P-47 knew that the next day he would face another, piloted by a new man, in a new machine, armed with the same 8 machine guns and the same amount of ammunition. It was a war of attrition, and exhaustion inevitably had only one side. Republica Aviation did not operate alone. General Electric produced the turbochargers that guaranteed performance at altitude. Hamilton Standard manufactured the wide-bladed propellers that gave the Thunderbolt its unmistakable sound, and the Remington and Browning supplied the machine gun lines with mathematical precision. The Lake City Armory in Missouri produced more than 30 million .50 rounds per month. In 1944 alone, the Thunderbolts consumed 10 billion .50 caliber ammunition. Each of them was manufactured with 0.01 inch of precision, a feat that turned metallurgy into a weapon. The American system was a living organism, where every civilian cog served the war. Meanwhile, in Germany, the airline industry was collapsing. Messerschmitt's factories in Regensburg were bombed weekly. Supply lines were fragmented. There was a lack of steel, a lack of fuel, and increasingly, a lack of time. Forced labor replaced skilled workers killed or displaced. Each new plane left the factories with defects, and many were destroyed before they even reached the front. Veteran pilots fell faster than they could be replaced. In 1944, the average lifespan of a newly graduated German fighter pilot was 11 days. The average training time for an American pilot before entering combat was 400 hours of flight time. Germany fought with talent, America with method, and the method won. The irony reached its peak. The plane that the Germans called a heavy monster was now the most replicated product in the world. The P-47 was no longer a symbol of a country, it was a symbol of an industrial civilization. Produced by men and women who had never seen a battlefield, the Thunderbolt represented the power to transform ordinary work into military force. More than 300,000 workers, many of them women, many immigrants, participated in its production. They worked 12 hours a day, riveting wings and assembling electrical panels. With each completed plane, a small symbol was drawn on the fuselage, a white star inside a blue circle. It was the signature of the factory and of the era. American power was not just in the quantity, but in the logistics that underpinned everything. Liberty ships crossed the Atlantic carrying engines, ammunition, and spare parts. The supply was so efficient that in the middle of the war, the United States was able to simultaneously maintain 3 air fronts in Europe, the Pacific, and the Mediterranean, with complete aircraft, fuel, and armament. No force in history had operated with such a level of coordination, and the numbers didn't lie. Between 1941 and 1945, the United States produced 300,000 fighter planes, Germany 119,000. The Allies had more fuel than the enemy had pilots. When General Adolf Galland was informed of these statistics, he replied bitterly, "We do not fight men, we fight a factory." He was right. The war that had begun as a contest of the skies ended as a contest of productivity. The P-47 became the icon of this philosophical transition. He was not handsome nor elegant. It was functional, robust, and nearly indestructible, a perfect symbol of what the United States had become. Each plane was a political statement. They would not win by the genius of one man, but by the coordinated force of millions. The German doctrine that war was an art had been replaced by the American idea that war was a system. The result was inevitable. In January 1945, Republic Aviation produced its 15,000th Thunderbolt. When the news reached the fronts, the German pilots could hardly believe it. Many of them flew with 1942 aircraft, maintained with repurposed parts. The Reich was struggling with leftovers, America with leftovers. It was the end of the line for an ideology that had mistaken heroism for effectiveness. But the story still held a final irony, because while American factories were pouring planes incessantly, a new threat loomed over Germany's horizon: jet fighters. The Messerschmitt Me-262, the Reich's last technological bet, promised to regain lost air supremacy, a fast, lethal plane powered by turbojets. But the thunder had not yet fallen still, and when the German jet finally took off, it encountered the same old adversary in the sky, the P-47, an airplane made of aluminum, sweat, and industry, ready to prove that even the speed of the future could be brought down by the weight of the present. At the end of 1944, the sky of Europe changed its sound. The deep roar of the radial engines gave way for a moment to a high-pitched metallic whistle, a new, cutting, almost unreal sound. It was the Messerschmitt Me-262, the first operational jet fighter in history. For the Germans, it was the promise of redemption. The Luftwaffe, now in ruins, saw in the new plane its last hope of reversing fate. With a speed of more than 850 km/h, the Me-262 was almost 200 km/h faster than the P-47 Thunderbolt. Their guns, four 30mm Mk108 cannons, could tear a bomber to pieces with a single shot. When the first jets crossed the sky, the Allied pilots were in shock. A new kind of war had begun. German technology finally seemed to have surpassed American power. But as so often before, the appearance would be deceptive. The jets were fast, but fragile. J-2 fuel was scarce and unstable. The Junkers Jumo 04 engines had an average service life of only 25 flight hours. The start was slow. The turbines took almost a minute to reach full power, and in the meantime, they were vulnerable. The Reich had created the future, but the future had no time, no fuel, no pilots. The P-47, heavy and seemingly outdated, still dominated the skies with the same invisible weapon that had sustained it from the beginning: reliability. While the Me-262s struggled to keep up, the Thunderbolts flew 3-4 missions a day. The secret of American victory remained the same: the power of repetition. The clashes between the old Thunder and the new jet soon began. On 7 October 1944, the 78th Fighter Group encountered a squadron of Me-262s over Brussels. Captain John C. Mears dived into one of them from 25,000 feet. The speed of the P-47 exceeded 880 km/h, close to the sound barrier. The 50 machine guns spewed out a rain of fire. 3 seconds later, the German jet exploded in mid-air. Mears almost lost control of the aircraft as he crossed his own wake, but managed to recover and return to base. When it landed, the radio echoed the message that would become a symbol of that winter: "The thunder has struck down the lightning." This irony wasn't just poetic, it was scientific. The P-47 was not a pretty plane nor a revolutionary, but it was the pinnacle of functional engineering. The weight, so often a source of ridicule, made it stable in extreme dives. Its massive structure withstood forces that destroyed the wings of lighter fighters. And most of all, he could fly, always fly. The Me-262, on the other hand, relied on an infrastructure that Germany no longer had. There was a lack of tracks, mechanics, parts. The synthetic fuel that powered the jets was produced from coal, in refineries that were constantly bombed. The result was brilliant but powerless technology, a jewel surrounded by ruins. While the Germans desperately tried to preserve their jets, the Thunderbolts turned into runway hunters. The units of the 9th Air Force were given direct orders to attack the airfields where the Me-262s were based. The sound of the Donnerschlag echoed again, this time over the bases of Lechfeld, München and Rheine. The P-47s patrolled the skies, waiting for the moment when the jets, slow and vulnerable, needed to land. It was the revenge of simplicity, a propeller-driven plane hunting a turbine-powered one, and one by one the jets began to fall. Oberleutnant Franz Kutscher, pilot of Me-262, described the scene in his diary. "We had the future in our hands, but not the ground to take off. Every time we took off, the enemy was already waiting when we returned. It was like fighting against time. Within a few months, the Luftwaffe lost almost all of its jets. Of the approximately 400 Me-262s produced, less than 300 made it to combat, and of those, more than half were shot down during landings or takeoffs, many by P-47s. What was supposed to be tomorrow's weapon had become the epitaph of the present. The contrast between the two philosophies reached its climax. Germany created extraordinary machines, but they were unable to sustain themselves. The United States produced ordinary but infinite machines. It was the synthesis of the century, genius without logistics against logistics without failure. One of the American pilots, Colonel Hubert Zemke, described the feeling in a phrase that became the motto of the squadron: "They built the future. We knocked it down with mass production." The phrase spanned generations, a brutal portrayal of the industrial truth of war. Even with the introduction of jets, Thunderbolt maintained its dominance in the skies. By 1945, the statistics were indisputable. The P-47s had flown more than 746,000 sorties and destroyed more than 100,000 ground targets. No other fighter, neither before nor since, has accumulated such devastating numbers. The Luftwaffe, reduced to a handful of veterans and teenage recruits, had nothing else to oppose. The German runways were covered in debris and smoke. The high-pitched sound of the jets had been swallowed up by the deep roar of the American engines. The irony of this story is that the solution was in front of them all along. The plane that the Germans called too slow was the same one that won the final race against time. If you're enjoying unraveling these facts and want to continue exploring the technical behind the scenes that changed the war, show your support. like and subscribe. This helps to keep the research alive and to bring to light stories that the dust of time has almost erased. In the last winter of the war, the P-47 patrolled over Germany with the calm of someone who already knew the end. The Luftwaffe, in ruins, saw its hangars burn and its fields become iron graveyards. What remained of German hope now was only the distant sound of jets trying to take off, followed, soon after, by the thunder that engulfed them. The Me-262 was the plane of tomorrow, but tomorrow had arrived too late. And when the Reich finally collapsed, covered in the smoke of its own innovations, the P-47 was still flying over Berlin, heavy, immortal, and with the same roar that had silenced all laughter 2 years earlier. But the thunder would not end there, because in the ruins of the Reich, a new era was about to dawn, and the world would see what happens when war ceases to be an invention and becomes a global industry. In 1945, the sky of Europe was no longer a battlefield. It was a spreadsheet. Every mission, every plane, every death could be reduced to a statistic, and they all pointed in the same direction: the total collapse of the Luftwaffe. The empire of aces, which had once dominated the continent with audacity and technique, now crumbled before an equation it could not win. There was a lack of pilots, fuel, parts, and above all, time. The enemy was no longer the P-47 itself, it was the factory that produced it. Each Thunderbolt shot down was replaced by an identical one, ready in a matter of hours. Germany, on the other hand, saw its air force slowly die from exhaustion. The airfields were full of planes without fuel, and the skies were empty of men to fly them. It was the mathematical end of a doctrine based on individual talent. The Luftwaffe had been born out of the belief that air warfare was a duel between geniuses. Men like Galland, Hartmann, Marseille, pilots who dominated the air by intuition, maneuver, courage. But in 1944, this air aristocracy no longer existed. Of the more than 30,000 pilots trained before the war, fewer than 2,000 remained. Most had died, been captured, or were incapacitated. New recruits had, on average, only 110 hours of flight time, with less than 40 in fighter jets. Some took to the skies without ever having fired a real weapon. They were 18-year-old boys, pitted against American veterans who had trained 4 times as hard. The difference wasn't just one of skill, it was structural. The Luftwaffe produced individuals. America produced armies. In the United States, the pilot training system operated as an industrial network. Flight schools spread across Texas, California, Arizona, and Florida operated in 3 shifts, 24 hours a day. The process was precise, timed, and relentless. Each pilot completed 400 hours of flight time before being assigned to combat, more than twice as many as any German at that point in the war. The simulators, theoretical instructions, manuals, and training practices standardized the experience. The result was predictability. When one American was shot down, another took his place with the same training, the same tactics, and the same plane. Air warfare had ceased to be an art and had become an industry. Meanwhile, in Germany, fuel was more valuable than man himself. Each hour of flight cost synthetic oil that no longer existed. Luftwaffe reserves fell from 180,000 tons a month in 1943 to less than 20,000 in early 1945. At some training camps, instructors pretended to take off with engines off to save fuel. The new pilots memorized flight manuals without ever touching the controls. When they finally entered combat, many did not even know how to operate the radio correctly. An internal Luftwaffe report from that year admitted, "Our young pilots die before they learn to fight." It was human obsolescence in the face of enemy industrial efficiency. The contrast between the forces had become grotesque. The US 9th Air Force had more than 2,000 operational P-47s in Europe, refueled, maintained, and armed by a logistics chain that began in Kansas and ended in France. The Reich, in this same period, was able to field less than 300 fighters on the entire Western Front. The difference in human resources was equally brutal. While the Americans trained 30,000 new pilots a year, the Luftwaffe managed to train only 2,000 and lost that number in a single month. It was a war that could no longer be won bravely. Individual heroism had become irrelevant in the face of mass production. The skies that once echoed the elegant maneuvers of German aces now belonged to mechanics. Formations of Thunderbolts and Mustangs crossed the horizon like columns of flying steel. With each mission, the destruction statistics grew. By March 1945, Allied reports counted 10,000 vehicles destroyed by fighter bombers alone. It was war reduced to the arithmetic of the impossible. General Adolf Galland himself, a former commander of the Luftwaffe, would confess after the conflict. In the end, every American pilot they shot down was replaced in days. Every pilot of ours who crashed was a library that burned. The ruin of German training was reflected in the tactics themselves. What had once been an aerial ballet had turned into despair. Luftwaffe fighters began to take off in isolated pairs, without coordination, often without radar or functional radio. The attacks were improvised, the formations chaotic. One pilot captured in 1945 reported that he had received only 2 weeks of instruction before facing Thunderbolts. Such was American superiority that the Luftwaffe itself began destroying its planes on the ground, unable to keep them in the air. On the other side of the Atlantic, factories continued at full pace. While Germany tried to save bullets, the United States manufactured 15,000 Thunderbolts, 15,000 Mustangs, and tens of thousands of bombers. Each of these planes required 60 tons of aluminum, and the United States produced 1.5 million tons of the metal per year. The scale of the war had exceeded any human limit. The US military could lose more planes in a week than the Luftwaffe was able to manufacture in a month, and yet it moved forward. In the skies over Germany, the last veteran pilots tried to keep their honor intact. They were men like Erich Hartmann and Walter Nowotny, symbols of an era that was disappearing. But even they knew that the struggle was in vain. Skill, instinct, and courage were worth nothing against statistics. Man's war against machine was over, and man had lost. The Luftwaffe died not for lack of courage, but for lack of gasoline and time. The final irony was cruel. The P-47, the heaviest and seemingly least refined plane of the conflict, had become the symbol of total efficiency. It represented the triumph of the system over the individual, of production over genius, of constancy over improvisation. The Reich, who had believed in the strength of his aces, succumbed to an adversary who believed in factories. And so it was that, in the last winter of the war, Germany discovered the true face of defeat, not in the bombs that fell, but in the inability to replace them. The Thunderbolts kept flying, unstoppable, like steel clocks. Each time one fell, another appeared. Every time a German died, no one came to his place. The war had been won before it was even over, and the clatter of American propellers buzzing over the devastated fields of Europe was not just the sound of victory. It was the sound of the extinction of an era. But the Thunder still had one last role to play, and its final mission would come when the enemy was no longer in the skies, but hidden among the ruins of Germany itself. When the war ended and the noise of the propellers finally fell silent, silence remained, and in it, the bitter reflection of those who once laughed. Luftwaffe pilots, now prisoners or survivors of a defunct army, looked at the wreckage and understood the size of the mistake. The plane they had called the Flying Barrel, Metallic Cow, and Roosevelt's piano had become, ironically, the final sound of their defeat. Adolf Galland, the ace who had embodied the pride of German aviation, declared years later in testimony, "We underestimated the P-47. We thought that the air war was won with elegance. They proved that you win with persistence." It was the confession of an entire era, a generation that believed that the art of flight was enough, not realizing that the world was being shaped by gears, assembly lines, and endless fuel. Josef Priller, the legendary commander of Jagdgeschwader 26, would also remember the moment when he first heard the sound of the 850 machine guns firing in sync. "We called it Roosevelt's piano," he wrote, but after the first concert, no one forgot the sound. The initial sarcasm had turned to reverence. The P-47 was no longer a joke. It was an audible memory, etched into the collective unconscious of those who survived. Every attack, every dive, every distant thunder became part of a bitter memory, the sound of inevitability. These testimonies reveal a rare phenomenon in military history, respect born of fear. Galland, Priller, Steinhoff, and so many other veterans admitted that in the end, it was not the American driver that scared them, but the constancy of the machine. The P-47 represented something the Germans had never fully understood, the industrialization of courage. The American pilot didn't have to be an ace. I just had to comply with the protocol, follow the pace, squeeze the trigger, and go back to refueling. The machine would do the rest. The Luftwaffe, which had glorified the individual, discovered that the individual could do nothing against the system. The post-war reports compiled by the Allies included accurate observations of German prisoners. In a document dated 1946, a former squadron commander wrote, "The P-47 was invincible because it never fought alone. Where there was one, there were 20. Where there were 20, there was the whole sky." Another, more bitter, added, "We don't fight planes, we fight US industry." This phrase would be cited decades later as the synthesis of the German defeat. The colossus that had bet on genius and discipline had succumbed to production and mathematics. The surviving pilots carried the physical memory of fear. Many spoke of the sound before the attack, that deep, distant roar that made the stomach shrink. The Donnerschlag, the American thunder, had become almost a myth. Even in the decades since, veterans have reported nightmares about the sound of blades cutting through the air. One of them, Hans Ulrich Stahl, summed it up in a letter published in 1963. "The noise came first. The sound got louder, and we knew the ground was going to disappear. Then silence. Always the same silence." Modern war had ceased to be just destruction. It had become a sensory, sound, psychological experience. Among the wreckage of the Reich, the perception of the enemy changed. The P-47, which had been a laughingstock, was now studied, dismantled, photographed. Imprisoned German engineers analyzed its structure with astonishment. The redundant systems, the turbocharger capable of maintaining power at extreme altitudes, the protected electrical system, the pressurized cockpit. One of them commented, "We try to make art. They did engineering." The phrase, "dry and precise," was the sentence of technological warfare. Recognition did not come only from the heavens. German ground troops also witnessed the impact of the Thunderbolt. In memoirs published by Wehrmacht officers, the name P-47 appeared more frequently than any other Allied fighter. It was the invisible enemy, the sound that preceded the fire. A soldier from the 2nd Panzer Army wrote, "We didn't see the plane, we only listened to him. The sound was like a sentence. No one fired, no one spoke. We just waited." To them, the P-47 was more than a machine. It was the harbinger of collapse. Over the years, the irony of the story has solidified. The plane that had been scorned as a design error became the symbol of American triumph and the embodiment of German defeat. Post-war, when the United States and West Germany became allies, many of these former enemies returned to see the Thunderbolt in exhibitions and museums. The reaction was always the same: silence. In 1951, during a visit to a NATO base, the now General Adolf Galland was invited to climb into a preserved P-47. As he put his hand on the fuselage, he said only, "Made to last, that's what defeated us." The transformation of contempt into respect was, in itself, a moral lesson. German technical pride, so focused on individual perfection, could not resist the impersonality of the machine. The war had changed forever. The P-47 didn't just represent American victory, it represented the birth of the era in which power would be defined by scale, not talent. Germany had built the fastest fighters, but America had built the ones that never stopped flying. And in the end, flying longer was the same as winning. Decades later, military historians would revise the numbers and confirm the magnitude of the feat. The P-47 Thunderbolt flew more than 746,000 missions, dropped 132,000 tons of bombs, and fired 135 million shells. No other fighter of World War II equaled this destructive capability. Its psychological impact was so great that in 1945, a survey conducted among captured German soldiers revealed a striking fact. 63% of them feared the sound of the P-47 more than any other Allied plane. It was laughter converted into trauma, mockery transformed into auditory memory. The end of laughter was also the beginning of respect, because, after all, the German pilots understood that the P-47 was not just an airplane, it was the expression of a civilization, a society that had replaced isolated genius with collective efficiency, who will turn each bolt into a gesture of power, and that would prove to the whole world that the secret of victory was not in flying faster, but in never stopping building. But the story was not over yet. When the engines fell silent and the fields of Europe became graveyards of steel, something new began to emerge. The Americans, now victors, looked to the sky for a substitute, a new generation of thunder. And what would be born from it, fueled by the lessons of Thunderbolt, would redefine not only aviation, but the very concept of world power. At the end of World War II, when the skies of Europe turned blue again and the sound of engines disappeared, The P-47 Thunderbolt was no longer just an airplane. It was a mirror of the world that was being born. Their victory was not only in the numbers, the missions, or the tons of steel dropped on Germany. It was in what it symbolized, the transformation of war into an industrial science and of production into a form of absolute power. The Thunderbolt represented the era when collective effort replaced individual heroism and engineering replaced intuition. It was the triumph of method over instinct, of machine over myth. While the Luftwaffe believed in legendary aces, the United States believed in systems. Systems that never slept, never rested, and most of all, never failed to manufacture. Each bolt on the P-47 carried a philosophy. He wasn't light because he didn't need to be. It wasn't beautiful because it didn't need to please. It was functional, reliable, and infinitely reproducible. The Pratt & Whitney R2800 engine was a masterpiece of redundancy. 2,000 horsepower powered by a turbocharger, capable of operating at times when air was almost non-existent. The fuselage, reinforced by overlapping spars, could withstand forces of up to 12 Gs without breaking apart. Each electrical circuit had a duplicate, each system a plan B. It was the opposite of German design, which bet on elegance, complexity, and perfection. Thunderbolt is designed not to be the best plane, but to never stop working, and this detail, this mechanical stubbornness, is what has redefined modern warfare. The sky became the direct reflection of the factories. What was seen at altitude was only the visible tip of a colossal network of production, transport, and maintenance. Behind each P-47 was a chain that started at the blast furnaces of Pennsylvania, passed through the hangars of Farmingdale, and ended in the makeshift workshops in France. It was an airplane made by an entire continent. American power was in its logistics. A German airplane was the product of a workshop. A Thunderbolt was the product of a civilization. When the propellers turned, it was the US economy that flew. While the Luftwaffe celebrated the individual talent of its pilots, America celebrated the anonymous efficiency of its workers. Thousands of women who had never seen an airplane before the war assembled their wings, fitted cables, riveted panels. They were the true heroines of Thunderbolt. None of them would be remembered as an ace, but without them, the thunder would never have roared. This was the new logic of power. Victory no longer depended on a few notable men, but on millions of invisible workers. The P-47 was not a monument to a genius. It was a monument to the crowd. The American philosophy was simple and devastating. If an airplane can be built, it can be replaced. With every Thunderbolt shot down, another left the assembly line. For each pilot lost, another arrived, trained, equipped, and prepared for the same mission. The war had become a stream, a continuous stream of production and replacement. Germany, with its artisanal tradition and its fetish for excellence, has failed to comprehend this change. He tried to fight the future with the past. He tried to beat a system with talent. But talent does not multiply. The system, yes. The P-47 was the embodiment of that thinking. He didn't just fight. He persisted. It was the plane that came back even destroyed, that continued to fly without full wings, that brought back injured pilots and burning engines. His physical endurance reflected the industrial endurance of his country. When a P-47 returned to base, covered in holes and still landed, it was the perfect metaphor for the United States. Damaged but functional, wounded but unstoppable. American power was not in vulnerability, it was the ability to continue despite harm. The P-47 didn't just beat the Luftwaffe, he won over the European philosophy of war. The fight is no longer a duel and has become an equation. The engineer replaced the rider. The production schedule replaced the plan of attack. Victory no longer depends on chance, and now depends on maintenance. It was the first time in history that a war had been won in both factories and battlefields, and the Thunderbolt was the perfect symbol of this new era. Decades later, historians would identify the P-47 as the turning point between two worlds, that of individual courage and that of collective efficiency. He ushered in the era in which power was measured not in bravery, but in tons of aluminum and barrels of fuel. The real battlefield was not in the skies of France, but in the treadmills of American factories. There, without heroism, without applause, men and women produced what the Luftwaffe could never understand: constancy. Even the enemies recognized this transformation. At a veterans conference in 1985, Adolf Galland summed up the significance of the defeat. "We didn't lose to the P-47, we lost to what he represented. America has understood that modern warfare is a matter of engineering, not glory. His words echoed as the inevitable conclusion to an irony that had begun in 1943, when German pilots laughed at the sight of the silhouettes of the Thunderbolts for the first time. 2 years later, they already knew that laughter had been the sound of an old civilization being replaced by a new one. The P-47 Thunderbolt was not the fastest plane, nor the most maneuverable, but he was the most consistent with his time. He reflected the American spirit, voluminous, direct, excessive, relentless. It was a machine that didn't ask permission to win. By the time the war ended, Thunder had done its job, not just defeating an enemy, but defining how the world would understand power from then on. And so, the laughter that began in the skies of France turned into doctrine, into learning, into legacy. The sound of the P-47 was not only the thunder of victory, it was the echo of the industrial century, the metallic noise of the new world taking the place of the old. But there was still something to be said, because even after the war, the thunder did not fall silent. It spanned the decades, influencing generations of fighters, technologies, and doctrines. And that's when the story reaches its final climax, when the sound that was born in 1943 not only won the war, but shaped peace. They laughed when they saw the P-47 come up. They thought it impossible that an airplane so big, so heavy, so clumsy could pose any threat to the skies of the Reich. But when the 8 Browning machine guns began to roar, laughter dissolved into the air, and thunder began to echo above defeated Germany. The P-47 did not win by chance. He won because he was the physical expression of an idea, that modern warfare does not belong to the fastest, nor to the bravest. It belongs to those who build non-stop. The collapse of the Luftwaffe was not just military, it was ideological. Their doctrine of individual heroes, their cult of dexterity and technical pride, simply could not bear the weight of American steel, of constant fuel, of factories that never slept. The Reich collapsed, not because of a lack of courage, but because of an inability to understand that in the new era, courage could also be produced in series. The P-47 was the ultimate product of this logic, a machine that symbolized not the genius of one man, but the organized strength of an entire nation. The great lesson of this war is simple and universal. Logistics determines strategy. Volume wins over talent. Persistence defeats momentary brilliance. In the skies of Europe, what started as a duel between pilots turned into a duel between economies. America struggled with steel, aluminum, fuel, and rhythm. Germany fought with honor, technique, and faith, but history is not written with intentions. It is written with results. And the result was the unmistakable sound of Thunderbolt propellers streaking across the sky, reminding the world that victory belongs to those who know how to plan, produce, and resist. It was industry that overcame romanticism, constancy that overcame genius, silent work that defeated solitary heroism. Decades later, one of the German generals himself would bitterly admit, "We were defeated by trucks, not by soldiers." That phrase sums up the final irony of the story, the confession of an empire that believed it was fighting men, but found itself fighting a system. The thunder didn't just silence the laughter, it buried an era, and behind every propeller that turned was a truth that transcends the battlefield. There is no power without production. There is no victory without logistics. If you value research, truth, and the effort to rescue these real stories like this video, subscribe to the channel and activate the bell. This helps to keep alive the memory of those who built the victory with their own hands. And tell us here in the comments, what was the most shocking fact of this story for you? Because in the end, the P-47 was not just an airplane, it was a message. The metallic sound of industrial justice, the thunder that silenced arrogance and heralded the beginning of the modern world. He taught that true power is born of collectivity, discipline, and the ability to turn work into strength. And as we remember that thunder, the echo still resonates, not in the skies of France or Germany, but in the consciousness of every nation that has learned that war, first and foremost, is a test of human organization. Don't go away yet. Listen to the next real story that will appear on the screen. Always remember, logistics determines strategy. Watch the next video here on the channel, another incredible story where the impossible bows before the power of human persistence.